Let's talk about chemical reactions. So, just kind of a quick refresher. Anything in this column, so this is column number 1, or what we call group 1. Those are the alkali metals. And what's important about those is that they have one valence electron, or those outer electrons that we draw when we draw a Lewis dot structure. And then the next column over, this guy, that's group 2, and those are the alkaline earth metals. They have 2 valence electrons. So their Lewis dot structures look like this. 1, 2. Okay, so they have 6 empty spots in their outer shell. And these two groups are super important because they are really reactive. These two groups really like to interact with these groups over here. So group 2, the alkaline earth metals, love to react with group 6, the oxygen family. And that is because of what's called the octet rule. So the octet rule involves that second shell. The octet rule says that atoms or elements really want to have a full shell. So beryllium has 2 in its outer shell, its Lewis dot structure. That means that it has 2 valence electrons. And oxygen has 6. They would really want to combine because then they would have a full outer shell, a full valence shell of electrons with 8 electrons. Once they have these 8 electrons, they end up acting like this far column here. Remember, these are the noble gases. And they have this 8 electron configuration. They have a full valence shell. Remember, the noble gases, helium, neon, argon, etc., they really are not reactive. Super stable. They like to keep to themselves. Remember, they're really full, like ancient royalty, ancient kings and queens that have giant feasts. They're always full. They don't like to deal with this riff-raff over here. They just keep to themselves. The goal for elements is to obtain this noble status. They want to be full. They want to have the grand feast as well. So, let's talk about some chemical reactions then. Let's talk about salt. So salt is NaCl, or sodium chloride. Now, sodium, if you look back at your periodic table, has 1 valence electron. So its Lewis dot structure looks like this. If we combine it with chlorine, who has 7, we wind up, it yields sodium chloride, which looks like this. We have our 7 chlorine electrons around chlorine and 1 sodium. And this is a good example of what's considered an ionic bond. The sodium gave up its electron, it gave it away to chlorine. So this is an ionic bond, and that it gives away that electron. And we can recognize that it's an ionic bond because it consists of a metal bound with a nonmetal. So let's do one more example of this type of bond. Let's do sodium bromide. So if we have sodium, remember it has just 1 valence electron, and we add it to bromine, which is similar to chlorine. It also has 7 valence electrons, just like chlorine. If we take these reactants and they combine in an ionic bond, they will yield sodium bromide. So sodium bromide will look like this. And the sodium actually gave its electron away. So I'm going to actually erase sodium here if I can. Maybe I can't. So the final product will actually look like this. Bromine with a full valence shell, because this electron actually came from sodium. So now it's full. This is another example of an ionic bond because sodium gave away its 1 valence electron. So this is another reason why Lewis dot structures are so important. We can visually see if they're going to react or how they're going to react with each other, the different elements. So if you need to rewind this video, make sure you've taken good notes because you have that little quiz afterward. Don't forget.